Welcome, everyone. In this lecture, we're going to cover some really important foundational concepts in JavaScript. Specifically, we're diving into operators. We'll look at what operators actually are, the different types of operators you'll use all the time, and we'll also touch on the course schedule so you know what's coming up. Let's get started. Before we jump into the technical content, let's quickly go over the schedule. Tomorrow is the last Friday of the month, which means it's the month-end meeting day. Our mentors are joining from different locations, so instead of a regular class, we'll be having a meeting with the mentors at the usual time. That means no class tomorrow. To make up for it, 3 get-up videos will be posted tomorrow. Those videos are meant to carry you through until Sunday, so by Sunday, you should have watched all of those. Then, starting Monday, the goal is to complete JavaScript fully, and on the 30th and 1st, there will be Git practice sessions, followed by a Git revision on the 2nd. All right, so what exactly is an operator? Let's look at a simple example. When we write let a equals 1, we're doing a few things here. A is our variable, 1 is the value, and the equal sign in the middle, that's what's actually doing the work of assigning the value to the variable. That equal sign is what we call an operator. So in simple terms, an operator is a special symbol or syntax used in JavaScript to perform some kind of operation, whether that's assigning a value, doing math, or comparing ins. Let's look at another quick example. If you write 1 plus 2, the plus sign is joining those two numbers together. That plus sign, also an operator. So any symbol that performs an action between values is an operator. Now, operators in JavaScript come in several types. The 3 main ones we're going to focus on today are, first, arithmetic operators. These are used for mathematical operations like addition, subtraction, multiplication, and division. Second, assignment operators. These are used to assign values to variables. And third, comparison operators. These are used to compare 2 values against each other. Each of these plays a very different role, and you'll be using all of them constantly as you write JavaScript code. Let's go through each one in detail. Let's start with arithmetic operators. These are the operators you use for mathematical calculations. The plus sign does addition, the minus sign does subtraction. For multiplication, we use the asterisk symbol, that star-shaped character on your keyboard. For division, we use the /. And then there's one that sometimes confuses beginners, the modulus operator, which uses the % sign. We'll look at each of these with examples, but first, let's make sure we understand what each symbol looks like and what it does. Here's what these operators look like in actual code. If we have a equal to 10 and b equal to 3, then a plus b gives us 13, a minus b gives us 7, a times b gives us 30, and a divided by b gives us approximately 3.33. Now, the interesting one is the modulus. A % b gives us 1. You can verify all of these yourself by using console.log to print the results. The key takeaway here is that these are your standard math operations, and they work exactly the way you'd expect from basic mathematics. The modulus operator deserves a little extra attention because it's the one that trips people up the most. The modulus operator gives you the remainder after division, not the result of the division itself. So let's take 8 modulus 3. We ask, how many times does 3 go into 8? It goes in 2 times, because 3 times 2 is 6. But 8 minus 6 leaves us with 2 left over. That leftover amount, 2, is what the modulus operator returns. Think of it like splitting apples into equal groups. If you have 8 apples and you want groups of 3, you get 2 full groups with 2 apples remaining. That remainder of 2 is your modulus result. This operator is actually very useful in programming, for example, checking if a number is even or odd, or cycling through a list repeatedly. Now, let's talk about assignment operators. The most basic one is the simple equal sign, which we've already seen. When you write let a equals 5, you're using the assignment operator to store the value 5 inside the variable a. But there's more to assignment operators than just the equal sign. There's a whole family of compound assignment operators: plus equals, minus equals, multiply equals, divide equals, and modulus equals. These are shorthand ways of performing an arithmetic operation and assigning the result back to the same variable in one step. Let's look at what that actually means. Here's a great way to understand compound assignment operators. Imagine you have a wallet with 5 rupees in it. Someone gives you 10 more rupees. Now your wallet has 15. In code, the long way to write this is a equals a plus 10, meaning take whatever is already in a, add 10 to it, and store the result back in a. But that means you have to write a twice, which is a bit repetitive. The shorthand for exactly the same thing is a plus equals 10. These 2 lines of code do the exact same thing. The plus equals operator says take whatever is in a, add 10 to it, and put the result back in a. The same logic applies to minus equals, multiply equals, divide equals, and modulus equals. They all follow the same pattern. Perform the operation on yourself and store the result. Here's a complete example showing all the compound assignment operators in action. Starting with a equal to 10, if we do a plus equals 5, a becomes 15. Then a minus equals 3 brings it down to 12. Then a multiply equals 2 doubles it to 24. Then a divide equals 4 brings it to 6. And finally, a modulus equals 4 gives us the remainder of 6 divided by 4, which is 2. The instructor encourages you to try all of these yourself in the browser console. Type them out, run them, and see the results with your eyes. That hands-on practice is the best way to really internalize how these operators work. The third type of operator we're introducing today is the comparison operator. Comparison operators are used when you need to compare two values against each other. The result of a comparison is always a Boolean, meaning it's either true or false. Here's something interesting. You've actually already used a comparison operator without maybe realizing it. Remember when we wrote for loops? Inside the for loop condition, we wrote something like I less than 10. That less than sign is a comparison operator. It's asking the question, is I currently less than 10? If yes, the result is true and the loop continues. If no, the result is false and the loop stops. We'll go deeper into comparison operators in the next part of the series. Before we wrap up this section, let's revisit the schedule one more time so it's crystal clear. Tomorrow, Friday, there's no class because of the month-end mentor meeting. 3 videos will be posted to keep you on track through the weekend. By Sunday, you should have watched all of them. Monday is a big day. The goal is to fully complete JavaScript. Then on the 30th and 1st, you'll be doing Git practice. And on the 2nd, the instructor will run a revision session on Git to make sure everything is solid. So JavaScript completion and Git practice are the 2 big priorities coming up. Keep that in mind as you work through this week's material. So before diving deeper into operators, let's quickly cover the class schedule and assignment structure being discussed. There will be no live class the following day due to mentor availability. Instead, 3 Get Up assignment videos will be posted. These are meant to carry students through until Sunday. The key deadline here is Monday. JavaScript must be fully completed by then, starting from Sunday. The course transitions into Laravel, and if you have design-related questions, like the book career consultation design that was brought up, those will be addressed once Laravel sessions begin, since that's the appropriate context to tackle them. Now, let's get into comparison operators in JavaScript. A comparison operator is used whenever you need to compare 2 values, and we actually already saw one in action when we used the for loop earlier, where we wrote something like I less than 10. So comparison operators are not new. We've been using them. The full set includes less than, greater than, less than or equal to, greater than or equal to, and strict equal to. Let's look at a simple example. If we declare a equals 4 and b equals 3, and then we log a greater than b to the console, what do we get? The key thing to understand about comparison operators is that they always return a Boolean value, meaning the result is either true or false, nothing else. So when we compare a greater than b, where a is 4 and b is 3, the result is true, because 4 is indeed greater than 3. If we flip it and ask a less than b, the result is false. This Boolean output is what makes comparison operators so powerful. They're the foundation of all conditional logic in programming. One of the most common mistakes beginners makes confusing the assignment operator with the comparison operator. A single equal sign is the assignment operator. It assigns a value to a variable. So writing a equals 5 means you are storing the number 5 inside the variable a. But 2 equal signs, the double equals, is the comparison operator. It asks the question, are these 2 values the same? So a double equals b does not assign anything. It checks whether a and b hold the same value and returns true or false. This distinction is critical, and mixing them up is a very common source of bugs. Now, here's where it gets really interesting. The double equals operator only compares values. It does not care about the data type. So if we have the number 5 stored in variable a, and the string 5, that's 5 in quotes, stored in variable b, and we compare them with double equals, JavaScript will say true. Why? Because the values look the same to double equals. It performs what's called type coercion. It converts one type to match the other before comparing. So even though one is a number and the other is a string, double equals ignores that difference and just looks at the value. The triple equals operator, also called the strict equality operator, takes things one step further. It checks both the value and the data type. So using the same example, a is the number 5 and b is the string 5. When we use triple equals, JavaScript first checks, are the values the same? Yes, they are. But then it also checks, are the data types the same? No, one is a number, the other is a string. Because the data types don't match, the result is false. This is why triple equals is generally recommended in modern JavaScript. It avoids unexpected behavior caused by type coercion. Double equals can give you surprising results if you're not careful about your data types.
Let's put the two side by side to make this crystal clear. Double equals tracks only the value and performs type coercion, meaning it will try to convert types to make a comparison work. Triple equals is strict. It checks both the value and the data type and does no conversion whatsoever. So 5 double equals 5 gives true, but 5 triple equals 5 gives false. When both the value and the type are the same, like comparing the number 5 to the number 5, both operators return true. As a best practice, most JavaScript developers recommend using triple equals by default because it makes your code more predictable and avoids hard-to-find bugs.
Here's a complete reference table of all the comparison operators in JavaScript. Less than, greater than, less than or equal to, greater than or equal to. These four are fairly straightforward and work exactly as you'd expect mathematically. Then we have double equals for value-only comparison, triple equals for strict comparison of both value and type, and not equals for checking if two values are different. Remember, every single one of these operators returns a Boolean. That's the unifying rule. The result is always either true or false, and that output is what drives all the decision-making logic in your programs. Now that we've covered all the comparison operators, the next topic is logical operators. Logical operators allow you to combine multiple comparison expressions together. For example, what if you want to check whether A is greater than 2 and B is less than 10 at the same time? That's where the AND operator, written as two ampersands, comes in. There's also the OR operator, two vertical bars, and the NOT operator, an exclamation mark. These three logical operators are what let you build complex conditions, and they work hand in hand with everything we just learned about comparison operators. We'll be walking through examples of each one next. Let's also keep the bigger picture in mind. The course is progressing through a clear roadmap. Right now, the focus is on completing JavaScript, all the operators, loops, and core concepts. The 30th and 1st are dedicated to Git practice. On the 2nd, there will be a Git revision session to reinforce what was learned, and JavaScript will be wrapped up completely. From the 2nd onward, Laravel begins, and live classes will continue from there. Any design-related questions, like the book career consultation layout that was mentioned, will be addressed in the Laravel phase, since that's where design and full-stack integration becomes relevant. Notes and resources will be shared along the way. Picking up from where we left off, there's an important point being made here about Laravel and design. The instructor is explaining that when it comes to designing features in Laravel, you don't need to jump to a separate tool or framework. Instead, you look at how Laravel itself handles things. The specific example being discussed is a design where clicking a button opens a form, the user fills out that form, submits it, and the data gets saved to the database. This is essentially the foundation of CRUD, create, read, update, delete, and the instructor is pointing out that this entire flow will be demonstrated within Laravel itself. CRUD stands for Create, Read, Update, and Delete, and it represents the four fundamental operations you perform on data in any web application. When you fill out a form and submit it, that's create. When you view a list of items on a page, that's read. When you edit an existing record, that's update. And when you remove something, that's delete. The instructor is emphasizing that Laravel is the right place to learn and practice CRUD, and that the design examples being discussed, like a form that opens on a button click and saves to a database, are all part of this CRUD workflow. Now we move into one of the most important foundational topics in programming, logical operators. There are three core logical operators you need to know. First is AND, written as two ampersands, double ampersand. AND means both conditions must be true for the overall result to be true. Second is OR, written as two pipe characters, that vertical bar above your enter key, typed with shift. OR means at least one of the conditions needs to be true. And third is NOT, written as an exclamation mark. NOT simply flips the value. It turns true into false and false into true. These three operators are the building blocks of all conditional logic in programming. Let's talk about how you actually type these operators. The AND operator is two ampersand symbols. That's the %-looking character, typed by pressing Shift and the 7 key, written twice to make double ampersand. The OR operator is two pipe characters. The pipe is that vertical bar on your keyboard, located above the Enter key, and you type it by pressing Shift along with the / key. The instructor calls this the pipeline character. Type it twice to get the OR operator. and the not operator is simply the exclamation mark, typed once. These are the exact characters you'll be writing in your code, so it's worth getting comfortable finding them on your keyboard. The AND operator is best understood through a real-world example, a login page. When a user tries to log in, two things need to be correct: the email and the password. Both must be right. If the email is correct but the password is wrong, the login should fail. This is exactly what the AND operator enforces. If you write your condition using AND, the system checks both conditions, and only if both are true does it allow the login. The instructor makes a really important point here. If you accidentally use OR instead of AND in a login check, you'd be creating a serious security hole, because the system would let someone in if just the email matches, even with the wrong password. The OR operator is used when you want at least one of multiple conditions to be satisfied. The instructor gives a great practical example. Some applications let you log in either with your email address or with your mobile number. In that case, you don't need both to be correct, just one of them. So you'd use OR. If the email matches, great, log them in. If the mobile number matches, also great, log them in. Either one being true is enough. This is the key difference between and OR. And is strict, requiring everything to be true, while OR is flexible, requiring just one thing to be true. Choosing the wrong one can completely break your application logic, so understanding this distinction is critical. The NOT operator does exactly one thing. It flips a Boolean value. If something is true, applying NOT makes it false. If something is false, applying NOT makes it true. The instructor demonstrates this with a simple console log example. If you write not true, the output is false. That's it. It just reverses whatever value you give it. Now, you might wonder, when would you actually use this? The instructor gives a practical example. Imagine you fetched some data, and you want to check if that data does not exist. Instead of writing a complex condition, you can simply write not data, meaning if data is absent or falsy, do something. It's a clean, readable way to express the absence of something. Here's a very practical use case for the NOT operator. Suppose you make a request to fetch some data, maybe from a database or an API, and you want to handle the case where nothing came back. You could write if not data, then show an error message or redirect the user. Because if data is null, undefined, or empty, it's considered falsy in JavaScript and PHP. Applying not to a falsy value gives you true, so your if block runs. This is a much cleaner pattern than writing something like if data equals null or data equals undefined. The not operator lets you express this thing doesn't exist in a single character. The instructor notes this will become even clearer as you start working with real data in later lessons. The instructor brings up a really interesting real-world example to illustrate the not operator in action. There's a live offer running for a course, and the condition being checked is whether today's date falls outside the offer period. If the offer is no longer active, meaning not active, the system displays a message saying the live offer has ended. This is exactly the not operator at work. The logic says, if this offer is not currently running, show the ended message. Otherwise, show the regular course content. You can see how not makes this kind of conditional logic very natural and readable. Rather than checking if the offer is ended, you check if it is not active. Same result, but often more intuitive to write. So to bring the logical operators together, AND requires all conditions to be true, OR requires at least one condition to be true, and NOT simply flips the value. These three operators appear constantly in real programming, in login systems, form validation, data checks, and much more. The instructor points out that while these might seem abstract right now, their practical importance will become very clear as you start building real features. And speaking of important, the instructor teases what's coming next, the ternary operator. It's described as extremely important, something the instructor themselves learned about later in their journey and wishes they had known sooner. That's up next. Picking up from where we left off, the instructor walks through how database interaction works in a web application. The basic flow is straightforward. When a user clicks a button, a form appears. Once that form is filled out and submitted, the data travels to the backend and gets saved into the database. This is the fundamental cycle of most web applications. Click, fill, submit, save. The instructor emphasizes that students need to understand and follow this flow carefully as they build their projects. The instructor also touches on a related topic, embedding communication links in a web page. This includes links for WhatsApp, Skype, and telephone numbers. These aren't just regular hyperlinks, they're special protocol links. For example, a telephone link using the TEL protocol, when clicked on a mobile device, will directly open the phone's dialer and start a call. The instructor mentions that Skype links work similarly. He reassures students that he will teach them how to set these up step by step when they actually use them in a real project.
Before diving into the next major topic, the instructor briefly recaps arrays and objects. He confirms that arrays and objects have been covered completely in the previous session. These are foundational data structures in JavaScript. Arrays hold ordered lists of values, and objects hold key-value pairs. The instructor points out that these concepts will come up again when working with reactive forms and control flow, so it was important to get them solid first. With that recap done, it's time to move on to the next operator. Now we get to one of the most important operators in JavaScript, the ternary operator. The instructor describes this as an extremely important operator, one that he himself learned about relatively late in his programming journey. The ternary operator is also called the conditional operator because it works like a condition, similar to an if-else statement, but written in a single line. The syntax has two key symbols, a question mark and a colon. The condition comes before the question mark. If the condition is true, the expression after the question mark runs. If the condition is false, the expression after the colon runs. Let's break down the syntax carefully. The ternary operator has three parts, which is actually why it's called ternary, meaning three. First, you write the condition. This condition must evaluate to either true or false. There's no middle ground. Then comes the question mark. After the question mark, you write what should happen if the condition is true. Then comes the colon. After the colon, you write what should happen if the condition is false. The instructor is very clear. The condition can only produce two outcomes, true or false. Anything else is not valid. Here's the live example the instructor writes. The condition is, does 2 plus 2 equal 4? That's written as 2 plus 2 equals 4. Since that is indeed true, the first expression runs, console.log of correct, and the output in the console shows correct. The second expression, console.log of incorrect, is completely skipped because the condition was true. This is the ternary operator in action. Evaluate the condition, pick one of two paths. Done. Now the instructor flips the condition to show what happens when it evaluates to false. In the first example, he uses the not equal to operator, written as not equal to 4, which reverses the result. Since 2 plus 2 is equal to 4, saying not equal to 4 is false, so the console prints incorrect. In the second example, he changes the number to 6, so 2 plus 6 equals 8, not 4. That condition is false, so again, incorrect is printed. The key takeaway: when the condition is false, the expression after the colon always runs. The instructor also shows a practical, real-world example of where the ternary operator shines. Imagine you're building a countdown feature. If the number of days is exactly 1, you want to display starts today. Otherwise, you want to show how many days are remaining. With the ternary operator, you can write this entire logic in a single line. If days equals 1, the message is starts today. Otherwise, the message becomes the number of days followed by days remaining. This is exactly the kind of scenario where the ternary operator is preferred over a full if-else block. A student asks, is the ternary operator the same as if-else? The instructor confirms, yes, the ternary operator is essentially a shortcut for if-else. Both do the same thing, check a condition and run different code based on the result. The critical difference is that the ternary operator works in a single line. If you need to run multiple lines of code inside each branch, you should use a full if-else block instead. The ternary operator is best for simple, concise conditions, where both the true and false outcomes can be expressed in a single expression. To summarize the ternary operator, it uses two symbols, the question mark and the colon. It's also called the conditional operator. The syntax is condition, then question mark, then the true result, then colon, then the false result. The condition must always resolve to either true or false. It's a single-line shortcut for if-else, and it's best used when the logic is simple and concise. The instructor wraps up this topic and transitions directly into the next concept, the if-else control flow structure, which handles more complex conditional logic. Picking up right where we left off with arrays and objects, let's talk about something really important. Where does the data actually come from? When you're writing practice code, you manually type out an object, like person data, with a name and age. But in a real application, that exact same data, in that exact same format, comes from the backend server. The front end receives it and uses it. So the structure you've been learning to write by hand is the same structure you'll be consuming from an API. That's why understanding objects and arrays isn't just an exercise. It's the foundation of how real apps work. Now, when you use console.log to print an object, what shows up in the browser's developer tools console is not plain text. It's an expandable object. You'll see something like object with the properties listed inside. This is the developer tools console, not the web page itself.
So when you're debugging and you log a variable that holds an object, don't expect to see a clean sentence. You'll see the object structure. This is completely normal and actually very useful for inspecting your data. Now, we move into one of the most fundamental ideas in programming, if-else statements. This is part of what's called control flow, meaning we're controlling which code runs and when. The concept is simple. You check a condition. If that condition is true, one block of code runs. If it's not true, a different block runs, or nothing runs at all. Think of it like everyday decisions. If I'm hungry, I eat. Otherwise, I don't. That's literally what if-else does in code. Here's the basic syntax. You have a variable called score set to 75. The if keyword is followed by a condition in parentheses. That's where you ask your question. Then the code to execute goes inside curly braces. If the first condition isn't met, you can chain an else if, which means otherwise if this other condition is true. And finally, a plain else at the end catches everything that didn't match any condition above. With score at 75, the first condition, greater than or equal to 90, is false. The second condition, greater than or equal to 0, is true. So pass gets printed. Notice the structure: parentheses for the condition, curly braces for the code block. Here's a subtle but important distinction. If you write 3 separate if statements, each one is checked independently. They're 3 separate questions. But when you use else if, they form a single chain. Once one condition matches, the rest are skipped entirely. This is what you want when your conditions are mutually exclusive, like temperature ranges. You don't want to check all 3 every time. You want to find the right one and stop. That's the power of else if chaining. Think of it like a single sentence with multiple clauses. If this, otherwise if that, otherwise if the other thing. It's one continuous thought, not 3 separate ones. Let's look at a real example, a temperature checker. We have a variable called temperature, and we want to categorize it into ranges. Less than 0 is freezing cold, 0 to 20 is cold, 21 to 27 is normal, 28 to 32 is hot, and anything above 32 is very hot. With temperature set to 18, the first condition, less than 0, is false. The second condition, greater than or equal to 0 and less than or equal to 20, is true. So cold gets printed, and the rest of the chain is skipped. Notice how we use the AND operator to combine 2 conditions. Temperature must satisfy both bounds to fall into that range. Let's zoom in on the AND operator, written as 2 ampersands. When you write 2 conditions joined by AND, both of them must be true for the code block to execute. In our temperature example, we need temperature to be at least 0 and at most 20. If temperature is -5, the first condition fails, so the whole thing is false. If temperature is 25, the second condition fails, also false. Only when both are satisfied does the code run. This is how you define a range. You set a lower bound and an upper bound, and both must be met simultaneously. The else block at the end is your safety net. It has no condition. It simply runs when none of the conditions above it matched. In our temperature example, if the temperature is 38, it doesn't match less than 0, doesn't match 0 to 20, doesn't match 21 to 27, doesn't match 28 to 32. So it falls all the way through to the else block and prints very hot. You don't need to write a condition for else, because by the time you reach it, you've already eliminated every other possibility. It's the default case. Here's a practical workflow tip. While you're writing and testing your code, it's easier to just hard code a value. Set temperature to 18, run it, see what happens. Change it to 38, run it again. But once your logic is working, you can switch to using prompt, which pops up a dialog box asking the user to type in a value. That makes it interactive. The recommended approach is use a hard-coded value while building, switch to prompt when you want to test user input, and use code comments to toggle between the two. This way, you're not constantly refreshing and retyping values. You might be wondering, can't we just use the ternary operator for all of this? The answer is yes, but only when you have a single condition. The ternary operator is a shortcut. It's clean and fits on one line, which is great for simple true or false decisions. But if-else is designed for situations where you have multiple conditions to check in sequence. When you have 5 or 6 ranges like our temperature example, writing that as a ternary would be messy and hard to read. So the rule of thumb is one condition, use ternary. Multiple conditions, use if-else chains. Now let's cover increment and decrement operators. These are shorthand ways to add or subtract one from a variable. The double plus operator adds one and the double minus subtracts one. But there's an important distinction between where you place the operator. If you write A++, that's post increment, it uses the current value first, then adds 1. So if A is 4 and you log A++, you'll see 4 printed, but then A becomes 5. On the other hand, if you write ++A, pre-increment, it adds 1 first, then uses the new value, so you'd see 6 printed immediately. The same logic applies to decrement with double minus. This distinction matters most when you're using these operators inside expressions or print statements.
Let's walk through this step by step so the timing is crystal clear. We start with A equal to 4. When we log A++, post-increment, the value 4 is printed first, and only after that does A become 5. If we log A again on the next line, we see 5. Now if we log ++A, pre-increment, A jumps to 6 first, and then 6 is what gets printed. The key word here is timing. Post means after, so the increment happens after the current value is used. Pre means before, so the increment happens before the value is used. Decrement works identically, just subtracting 1 instead of adding. Before we move on, here's a set of practice tasks to solidify everything covered so far. First, try all the assignment operators, plus equals, minus equals, multiply equals, and so on. Second, practice comparison operators. Make sure you understand the difference between double equals and triple equals. Third, write a basic for loop. Fourth, take an array you've already created and loop through it using for each. Fifth, and this is a great exercise, build a mark sheet using if-else. Define ranges. 0 to 39 is fail, 40 to 59 is good, 60 to 79 is very good, 80 to 100 is excellent, and anything above 100 is invalid marks. And finally, experiment with increment and decrement. Place the operator before and after the variable and observe how the output changes. Hands-on practice is how these concepts really click. So when we have an object and we want to print it, the first instinct might be to just do console.logPerson, and that does work. It prints the entire object to the developer tools console. But here's the problem. That output is not human-friendly. You get this big object structure with all the keys and values together, and a regular user, or even a developer reading output quickly, doesn't want to parse through all of that. What people actually want is one piece of data at a time, just the name, just the age, just whether someone is a student. So to pull individual values out of an object, we use dot notation. You write the object name, then a dot, then the property name. So person.name gives you just the name, person.age gives you just the age, and person.isStudent gives you just that Boolean value. That dot in the middle is what says go inside this object and get this specific property. Let's think about this from the user's perspective. If you're building an app and you want to display someone's name on screen, you don't want to show the entire object, you just want the name. The whole object output with curly braces and key value pairs is a developer debugging tool. It's not something you'd ever show to an end user. So the rule of thumb here is when you need a specific piece of data from an object, always use dot notation to extract just that value. That's what makes your output clean, readable, and actually useful. Now, here's a very practical situation. Suppose your data has the number 25 stored as the age, and you want to print it as 25 years old. The number 25 comes from the object. It's a numeric value, but years old is just a piece of text, a string. How do you combine them? You use the plus operator. In JavaScript, when you add a number and a string together using plus, it automatically converts the number to a string and joins them. So person.age plus the string years old gives you 25 years old as a single combined output. One thing to be careful about, spaces. If you write years old without a leading space, you'll get 25 years old all jammed together. A space is also a character. It's also part of the string. So always include that space where you need it. This technique of joining values together using plus is called string concatenation. Here's a really important real-world concept. When data comes from a backend server, like a salary or a price, it comes as a plain number, something like 249, just the digits, nothing else. The backend doesn't send RS249 because the RS symbol is a string, not a number. Numbers don't carry currency labels or symbols with them. So if you want to display RS249 to the user, that's your job on the front end. You take the numeric value from the object and you concatenate the RS string in front of it. This is a perfect example of why string concatenation matters. You're combining backend data with front-end formatting to produce a human-readable result. Now let's talk about arrays. While objects use dot notation to access data, arrays use something called indexing. Every item in an array has a position number, called an index, and that index starts at 0, not 1. So the first item is at index 0, the second at index 1, and so on. To access a specific item, you write the array name followed by square brackets, and inside the brackets you put the index number.
So courses at index 0 gives you math, courses at index 1 gives you science, and so on, all the way through the array. This is straightforward when you know exactly how many items are in the array and you're writing the code yourself. Here's where manual indexing becomes a real problem. Imagine you write code that manually accesses every index from 0 to 5, 6 lines of code, 1 for each item. That works fine right now. But what happens if the backend deletes one item? Suddenly there are only 5 items, and your code still tries to access index 5, which no longer exists. You'll get undefined or an error. And the bigger issue is, you don't control the backend. The data coming in could change at any time. Items can be added, removed, or reordered. If you hardcode every index manually, your code breaks the moment the data changes. You'd have to go back and update your code every single time. That's not practical at all. The solution to this problem is to use a for-of loop. Instead of manually writing one line per index, you write a single loop that automatically goes through every item in the array, however many there are. If the array has 6 items, it runs 6 times. If the backend sends 10 items, it runs 10 times. If one item gets deleted, it adjusts automatically. You never have to change your code. The syntax is simple: for const item of array name, and inside the loop body, you do whatever you want with each item. This is the standard recommended way to iterate over arrays in JavaScript. Manual indexing is really only used in specific situations. For general array printing and processing, the for-of loop is the right tool. Now let's look at 2 very commonly used operators in JavaScript, the increment and decrement operators. The increment operator is written as 2 plus signs right after a variable, like count++. What it does is automatically add 1 to the current value of that variable. So if count is 5, after count++, it becomes 6. The decrement operator is the opposite, 2 minus signs, like count minus minus. It automatically subtracts 1 from the variable. So if count is 5, after count minus minus, it becomes 4. These might seem simple, but they're used constantly in programming, especially in loops. Every time a loop needs to move to the next index or count how many times something has happened, the increment operator is doing that work behind the scenes. Here's exactly why increment matters so much. When you use a traditional for loop to go through an array, you start with a counter variable, usually called I, set to 0. Each time the loop runs, I++ adds 1 to I, moving you to the next index. So first you access index 0, then 1, then 2, and so on, until you've gone through every item. Without the increment operator, the loop would just keep accessing index 0 forever. It would never move forward. The I++ is what drives the loop through the array step by step. This is one of the most fundamental patterns in all of programming, and understanding that plus plus is just add 1 to this variable is the key to understanding how loops work. There's actually a subtle distinction worth knowing about, the difference between prefix and prefix increment. When you write I++, that's called postfix. The plus plus comes after the variable name. When you write plus plus I, that's called prefix. The plus plus comes before. The difference is about when the increment happens relative to when the value is used. With postfix, the current value is used first, and then it gets incremented. With prefix, the increment happens first, and then the new value is used. In practice, when you're just using increment inside a loop to move to the next step, this difference doesn't matter at all. Both forms will produce the same loop behavior. But it's good to know the terminology, postfix and prefix. You'll hear these terms in interviews and documentation, so now you know what they mean. Continuing from where we left off with arrays and indexing, now let's talk about looping structures, specifically the for-each loop. So what is a loop in the first place? A loop is simply a mechanism where the same block of code repeats over and over. Think of it like a frame that keeps running the same action. Now, the for-each loop is specifically designed to go through every single item inside an array. However many items are in that array, the loop will visit each one, in order, from the first to the last. So why do we use the for-each loop specifically? The main reason is to access and use the data that lives inside an array. If you want to print every element or do some operation on each item, the for-each loop handles that automatically. You don't need to manually track an index number. The loop knows how many items are in the array and visits each one. In this example, if the array has 3 items, apple, banana, cherry, the loop runs exactly 3 times, printing each item in sequence. Now, to understand the for-each loop fully, we need to understand where it lives, and that is inside what's called control flow. Normal program flow is simple. The computer reads your code from top to bottom, line by line. But control flow changes that. It redirects execution. It can make the program loop, branch, or skip sections. The for-each loop is one of the tools that lives inside control flow.
When the program reaches a for each loop, instead of just moving to the next line, it enters the loop and repeats a block of code for every item in the array. Let's make the connection between control flow and the for each loop very clear. When you want to print or process data from an array, you use a for each loop. That for each loop is a control flow structure, meaning it controls the direction and repetition of your program's execution. You enter control flow, you find the for each loop. The loop runs once for every item in the array, and then once all items have been processed, the program exits the loop and continues normally. This is the fundamental pattern you'll use constantly when working with arrays. Now, there's an important terminology point that came up, the difference between prefix and suffix, also called postfix. These terms describe where an operator is placed relative to a variable. A prefix means the operator comes before the variable, like writing ++i, where the increment happens before the value is used. A suffix or postfix means the operator comes after the variable, like writing i++, where the value is used first and then incremented. Both the terms postfix and suffix are used in different contexts. Suffix is more of a linguistic or grammatical term, while postfix is the term more commonly used in programming. Let's look at the practical difference between prefix and postfix increment. With prefix, written as ++i, the variable is incremented first and then its new value is used in the expression. With postfix, written as i++, the current value is used in the expression first and then the variable is incremented afterward. So if I starts at 5, prefix gives you 6 immediately, while postfix gives you 5 in the current expression and then updates I to 6 for the next use. The same logic applies to decrement as well, though decrement is less commonly encountered in everyday array work. When it comes to array indexing and looping, understanding prefix versus postfix becomes practically important. If you use prefix increment inside an array access, you skip the first element because the index is incremented before it's used. If you use postfix increment, you access the current index first and then move forward, which is the standard and expected behavior when looping through an array from the beginning. This is why in most array traversal loops, you'll see postfix increment, i++, rather than prefix. It ensures you start at index 0 and process every element correctly.
So to bring everything together from this section, we've now covered the for each loop and why it's the go-to tool for working with array data. We've placed it inside the broader concept of control flow, which governs how and when code executes. And we've clarified the terminology around prefix and postfix increment, which directly affects how array indices are managed inside loops. These aren't isolated ideas, they all connect. When you write a loop to process an array, you're using control flow, you're using increment operators, and you're relying on the for each structure to handle the repetition. Next, these concepts will be applied directly in hands-on array indexing and loop practice.
So let's talk about the for each loop, which is the go-to tool when you're working with arrays. The idea is beautifully simple. You have an array full of data, and instead of writing the same line of code over and over for each item, you write it once and let the loop handle the repetition. The for each loop visits each element in the array, one by one, and runs your code block for that element. In the example here, we have an array called even numbers with 8 values. Instead of writing 8 separate console.log statements, we write 1, using a variable like num to represent each item as the loop goes through them. The loop takes care of the rest, printing each value in sequence. Let's break down the for each syntax piece by piece so nothing feels mysterious. You start with the name of your array, in this case even numbers, then you call .forEach on it. Inside the parentheses, you give a name to represent each individual item as the loop runs. Here it's num, but you could call it anything you like. Item, element, I, whatever makes sense to you. Then comes the arrow and the curly braces. That's just the syntax of this particular style. Don't get hung up on the arrow symbol itself. What matters is that inside those curly braces is where you write the code you want to run for every single element. In this case, we're logging each number to the console. The arrow is just part of how JavaScript writes this. Different languages have different syntax for the same concept. Here's the real power of loops and why they matter so much in real development. Imagine you have an array with 8 items. You could write 8 separate console.log lines, one for each index. That's already tedious. But what happens when your array has 100 items, or 1,000? You'd have to write 1,000 lines. That's completely impractical. With a for each loop, you write the logic once, and it automatically handles however many items are in the array. Even better, if new data gets added to the array later, maybe from a database or an API, your loop just picks it up and processes it without you touching the code at all. This is the scalability that makes loops so essential in real applications.
Now let's apply for each to an array of objects, which is extremely common in real projects. Here we have a persons array, where each item is an object with a name and an age. When we loop through this array with for each, the variable p represents one full object on each iteration. So on the first pass, p is the Alice object. On the second pass, it's the Bob object, and so on. To access a specific property inside that object, we use dot notation. p.name gives us the name, and p.age gives us the age. We can also concatenate them together with a plus sign to print them on the same line. This pattern, looping through an array of objects and accessing their properties, is something you'll use constantly in web development. This is where loops connect directly to what you see on real websites. Think about a courses page. You have multiple course cards displayed, each with a title and duration. A developer doesn't design each card individually. They design one card template in HTML and CSS, and then they loop through the courses data and apply that template to each item. So if there are 3 courses, you get 3 cards. If there are 30 courses, you get 30 cards, all from the same single design. And here's the beautiful part. If someone adds a new course to the database, the page automatically shows a new card without the developer changing a single line of code. The data drives the UI. This is the fundamental principle behind dynamic web applications. Now let's move on to the for loop. While for each is perfect for going through every item in an array, the for loop is your tool when you know exactly how many times you want something to repeat. A classic example is building a multiplication table. You know you want to go from 1 to 10, so you set that up explicitly. The for loop has 3 parts inside its parentheses, separated by semicolons. First is the initialization. You create a counter variable and set its starting value, like let I equals 1. Second is the condition. The loop keeps running as long as this condition is true, like I is less than or equal to 10. Third is the increment. After each loop, you update the counter, typically by adding 1. These 3 parts work together to control exactly how many times the loop runs. Think of the for loop's parentheses as having 3 rooms, each separated by a semicolon. Room 1 is initialization. This is where you declare your counter variable and give it a starting value. You write let I equals 1, meaning the counter starts at 1. This room only runs once, right at the beginning. Room 2 is the condition. Before every single iteration of the loop, JavaScript checks this condition. If it's true, the code inside the curly braces runs. If it's false, the loop stops immediately. Here we have I less than or equal to 10, so the loop keeps going as long as I hasn't exceeded 10. Room 3 is the increment. After each iteration completes, this runs and updates your counter. I++ is shorthand for adding 1 to I, so I goes from 1 to 2, then 3, then 4, all the way up to 10. Let's trace through exactly what happens when this for loop runs. It starts by setting I to 1. Then it checks the condition. Is 1 less than or equal to 10? Yes, so it runs console.log and prints 1. Then I++ fires and I becomes 2. Check the condition again. Is 2 less than or equal to 10? Yes, print 2, increment to 3. This continues all the way through. When I reaches 10, the condition is still true. 10 is equal to 10, so it prints 10 and increments to 11. Now the condition is checked again. Is 11 less than or equal to 10? No, that's false, so the loop stops. Notice that 11 is never printed. The condition check happens before the code runs, so as soon as it fails, the loop ends immediately. This is why we get exactly 10 outputs, from 1 to 10. Now let's talk about one of the most common and dangerous mistakes beginners make, the infinite loop. This happens when your loop has no way to stop. There are 2 ways this can go wrong. First, if you forget the condition entirely, the loop just runs forever with no check. Second, and this is the more subtle mistake, if you forget the increment, your counter variable never changes. So if I starts at 1 and you never add to it, I is always 1, and I less than or equal to 10 is always true. The loop prints high over and over, hundreds of thousands of times until your browser or computer runs out of resources and crashes. This is called an infinite loop. The fix is simple. Make sure all 3 rooms are filled correctly. The condition must eventually become false, and the increment is what makes that happen by changing the counter value each time. A student asked about the difference between prefix and postfix increment. Great question. The double plus operator, I++, is called post increment. It means use the current value of I first, then add 1 to it. So if I is 5 and you write console.log of I++, it prints 5 and then I becomes 6. The prefix version, ++i, does it the other way around. It adds 1 first, then uses the value. So console.log of plus plus I when I is 5 would print 6, because I becomes 6 before being printed. The same logic applies to the decrement operator, I minus minus and minus minus I, which subtract 1 instead of adding. Now, in the context of a for loop, the distinction between prefix and postfix doesn't actually matter, because the increment step runs after the loop body completes either way. But it's good to know the terminology. Prefix means the operation happens before, postfix or suffix means it happens after. Operators are the fundamental tools you use to perform actions in JavaScript. Let's go through the main categories. Assignment operators, the single equal sign, assign a value to a variable. When you write let a equals 1, you're using the assignment operator. Arithmetic operators are your math tools. Plus for addition, minus for subtraction, asterisk for multiplication, slash for division, and the percent sign for modulus, which gives you the remainder after division. Comparison operators are especially important because they return either true or false. They're what you use in conditions. Double equals checks if two values are equal. Triple equals checks for strict equality, including type, greater than, less than, and their or equal to variants. And finally, the increment and decrement operators we just covered, plus plus and minus minus, for adding or subtracting 1. Understanding these operators is essential because they appear everywhere in JavaScript, especially in loop conditions and if-else statements. Let's zoom in on how comparison operators work inside loop conditions, because this is where a lot of confusion happens. In our for loop, the condition is I less than or equal to 10. This is a comparison operator, and it evaluates to either true or false on every single check. When I is 1, 2, 3, all the way up to 10, the condition is true, and the loop continues. The moment I becomes 11, the condition is false, and the loop stops. Notice the difference between less than and less than or equal to. If you use just less than 10, your loop would stop at 9, printing only 1 through 9. With less than or equal to 10, you include 10 in the output. This distinction matters a lot when you're building things like multiplication tables or generating a specific number of elements. Always think carefully about whether your boundary should be inclusive or exclusive. Just like we organize CSS into a separate folder and file, it's good practice to do the same with JavaScript. You create a JS folder inside your project, and inside it, a file called index.js. This keeps your project clean and organized. To connect this external JavaScript file to your HTML page, you use a script tag with a source attribute pointing to the file path, in this case, /js/index.js. Once that's linked, any code you write in index.js will run when the page loads, just as if you had written it directly inside the HTML. This separation of concerns, HTML for structure, CSS for styling, JavaScript for behavior, is a fundamental principle of good web development. It makes your code easier to read, maintain, and scale. Let's consolidate the difference between these two loop types so you always know which one to reach for. The for each loop is your array companion. Whenever you have an array of data and you want to do something with each item, for each is the natural choice. The number of iterations is determined by how many items are in the array, which might change dynamically. The for loop is your precision tool. Use it when you know exactly how many times something needs to happen. Building a multiplication table, generating a fixed number of elements, counting down from a specific number. These are all for loop scenarios. One important note, in frameworks like React, you'll often see the .map method used instead of for each for rendering lists. The concept is identical, it's just a different syntax for a similar purpose. The core idea of looping remains the same across all of these. Let's bring everything together with the key takeaways from today's session. Control flow is the foundation. By default, code runs top to bottom, and control flow tools let us change that. We have two main tools, if-else for conditional execution and loops for repetition. The for each loop is your go-to for arrays. It visits each element and runs your code on it, making it perfect for rendering dynamic content from data. The for loop is your precision repeater. Use it when you know exactly how many iterations you need, and always make sure your condition can eventually become false, or you'll end up in an infinite loop that crashes everything. And operators are the syntax glue that makes all of this work. Assignment, arithmetic, comparison, and increment operators all play a role. For practice, take the arrays you built in the previous session and try printing them using both for each and for loops. That hands-on repetition is what will make these concepts stick. Before we wrap up, here's the plan for the coming days. Today is Saturday, and the recording of this class will be uploaded. Along with it, 3 Git and GitHub tutorial videos will be uploaded all at once, so you can watch them at your own pace over the weekend. Sunday and Monday give you time to go through those Git videos. On the 30th and the 1st, use that time to practice Git and GitHub on your own. Then on the 2nd, there will be a revision session covering Git and GitHub, and we'll also continue with JavaScript to complete the remaining topics. Your homework right now is clear. Take the arrays you've been building and practice using both for each and for loops to print the data. The more you practice writing these loops yourself, the more natural they'll feel. See you on Monday.